Welcome back, Akira Bike Project fans. In the last video, we started work on the engine reduction cage, including building up the frame for that, and fixing the engine output spline to sprocket adapter. With the engine output adapter completed, I could move on to the next part of the engine redux cage, the large sprocket and large bevel gear shaft. Okay, I got these parts from Cut Sind. They do laser cutting and tapping. I've used them once or twice before, and it's pretty awesome, very reasonably priced, and pretty quick. The smaller disc gets welded to the 3/4 inch shaft, and then gets bolted to the larger disc, and the larger disc gets bolted to the sprocket. The idea here is that if I wanted to change the sprocket to one of a different size with a different number of teeth, all I would need to do is replace this larger disc with one that fit the bolt pattern of the inner smaller disc and the new sprocket. I jigged the shaft and small disc up in a bulky, rigid fixture made of clamps and 1-2-3 blocks. As far as I can tell, this is at a pretty good right angle in 2 axes, and I think I will give it a quick tack here and here, put it on the lathe, dial indicated. Let that dry, take it out, put it in the lathe. With the tack welded shaft and disc in the lathe, I checked the surface runout and did some tapping. Alright, now it's back up to 2.5. So I don't think I can beat that 2 thousandths where I'm at, so I'm going to go ahead and weld the opposite side of the high spot. With the assembly clamped in the lathe, I would meticulously add welds opposite the high sides to warp them in step by step. The ground is clamped to the chuck to prevent the current from running through any bearings inside the lathe. After about a half dozen tack welds, I had the runout still under 2 thousandths, so I think it was looking good. So I went ahead and started laying down some larger beads. With this side all welded up, I ended up under 5 thousandths runout, which is pretty good. Although since this is a face and not a turned shaft, I guess maybe that would be called face out? I'm not sure. Anyway, I did a quick fit test in the engine reduction cage frame with the bearings, and I was happy with the way it looked. I wanted to do a better job with the other side though, so I whipped up this Rube Goldberg-esque contraption using my rotary indexer and a drill and a vertical drilling guide and a belt and a pulley to make an improvised welding rotary table that just barely worked. With some 1-2-3 blocks and milling machine clamps and a larger disc for the table and an armrest, it wasn't that bad. Really not that bad at all. Definitely would like to add a legitimate rotary welding table into my toolkit though. After a few fits and starts, I welded the other half up the same way. with equally decent results. With that, it was time for a fit test. I mounted the sprocket to the large disc, and the large disc to the small disc and shaft I just welded, and put it in the engine redux cage with bearing blocks. Wow, nice. I was really liking the way that looked. I just had to slap a chain on it and see what that looked like. I quickly welded a 1/4-inch driver to that engine output sprocket adapter shaft and tested it with my drill. Feeling pretty good. This is starting to look like it will be a functional machine soon. The other side of that shaft would have the large bevel gear, and these gears have been around a while, though new would need a good cleaning. Inspired by the electric toothbrush and the desire to avoid tedious monotony, I screwed a metal wire brush to a reciprocal saw blade, and with that, along with some conventional wire brushing, got the rusty plaque off the metal teeth. They came out looking quite nice. Just look at that mercuric silver smile. The inner diameter of the large bevel gear opening, though, doesn't match the shaft, so I would need an adapter. I turned one on the lathe to match the ID and put some bevels on the end. I then bored out the inside to make sure it matches the shaft. A quick fit test looks promising. I'm going to need to cut a keyway into this adapter though, and I don't have a keyway broach or an arbor press, so after doing some research, I found some videos explaining how to make a keyway cutter. I started by drilling a hole through a piece of round stock, and then enlarging that to fit the cutting tool. The cutting tool is just a 1/4-inch square piece of high-speed cutting steel with a relief cut in the end. A hole is drilled from the end down the axis to the cutting tool mounting hole. That hole then gets threaded to hold a mounting screw which holds the cutting tool in place. The piece is then parted off and turned down to fit my largest collet. The large bevel gear is mounted in the milling machine, and these nuts are used as spacers to avoid damaging the teeth. The shaft cutting tool is manually moved up and down inside of the gear's shaft opening. Each downstroke removes just a few thousandths of an inch, and the tool is moved a few thousandths each time to make the next cut. It's a bit of a time-consuming operation that can take hundreds of passes. But the results could be absolutely phenomenal. You'll notice another keyway shaft on the other side of the gear. That's just a 3/16" keyway and won't really handle the torque here. That alignment looks great. Let's try it with the shaft key. Also excellent. I did the same operation on the smaller half of the bevel gear pair, but this time on the lathe. Fit testing it with shaft keys, and it still looks great. Those shaft adapter collars also needed keyways cut into them, but those were relatively easy cuts with an end mill. Overall, I think that shaft key cutting tool worked great. And rigging things up is starting to look really good and promising. That is it for this video. Thanks for watching. I'm getting really excited at how this is starting to look. This engine redux cage is a difficult part of the build and gets a little bit tougher as you'll see in the upcoming video. But things should really pick up pace after this assembly is done. I'd like to thank again all my existing patrons, and if you like the project, please become a patron yourself. Thanks again. See you soon.